Hello everyone, my name is Ray Lucchesi. I'm with Silverton Consulting, a storage industry analyst firm. I've been in the storage industry almost 37 years now. Much of it was with a former company called Storage Technology Corporation. We used to develop tape and disk systems for mainframes. It was purchased by Sun and then purchased by Oracle. Last 14 years I've been out on my own doing storage analyst work. I'd like to talk today about storage futures. How many people here, I'll say, are buying storage in the next 12 months? That's one. How many people here are selling storage in the next 12 months? That's 15, all right, hey! So I'm going to talk about storage technologies. I'm not going to talk about software-defined storage technologies because we had a lot of that discussion already today, but I'm going to talk about the hardware stuff. All right? Technology impacting storage. Yeah, hardware. Yeah, that's it. Yeah.
Wait,
so,
nobody said they're buying storage?
There's nobody else buying storage. There was one person buying storage, but there are 25 people here selling storage. You're not selling storage, are you? Yes, you are. All right, so everybody knows what happened. Disks, flash, fiber channel to networking. I'm not sure the networking is the right color, but close enough.
Are you going to cover tape today?
Am I going to talk about tape today? I am not going to talk about tape today. I can if you'd like. And then monolithic storage to software-defined stuff, kind of stuff. So what I am going to talk about is these technologies on this page here. The first one is Intel Micron 3D XPoint non-volatile memories. The second one is actually a skyscraper in Shanghai. No, actually it's a 3D TLC MLC NAND. Really. The third one there is shingled magnetic recording, which is the life of disk as we know and love it today, or in the future at least. And the fourth one is NVMe Express from our friends here at Intel. So let's talk about 3DX. It was announced in July. Flash Memory Summit, new generation of storage memory, non-volatile storage memory. First new generation of storage memory in decades. Manufactured by Intel Micron joint venture IM Flash. Potentially available in DIMMs, NVMe SSDs, PCIe SSDs, SATA SSDs, small cards, memory cards, SD cards. Today it's produced in layers, 3D already, so it can scale both horizontally and vertically. But right now, it's only 2 layers, or at least that's all they showed us. So what are the advantages? What are the advantages of 3DX? Why would somebody do 3DX? 1,000 times the NAND access time. So rather than being on the order of microseconds to access flash, storage, bytes, it's nanoseconds. It's almost on the level of, it is on the level of DRAM. It's just slightly slower than DRAM, maybe DDR4 or 3 or 2 or something like that. That's close. 1,000 times NAND write endurance. What's write endurance? How many times can you write that USB stick? What, 20, 30 times, 40 maybe? Then it just dies? Well, SSDs have a similar phenomenon. So they can only write so many times. So going from perhaps 1,000 write erase cycles to 1,000,000 write erase cycles is a significant advantage. It's got 10 times the DRAM density. Remember that point. So you can get 160 gigabits of 3DX in the same space you can get 16 gigabits of DRAM on chip. Roughly 7 times I/O performance in an NVMe SSD, form factor 95,000 K IOPS versus 95,000 IOPS versus at 9 microseconds versus 13.4 K IOPS at 73 milliseconds. Lower power, much lower power requirements than DRAM because there's no transistors in this memory. It's just whatever it is. It's not clear what it is, but it's not transistors. And it's non-volatile DRAM, and it could potentially be used, I believe, as real electronic logic. Now today, electronic logic is all transistor-based logic. I think this stuff can be used for logic. Although I tried to find the actual reference where I found that, I could not find that again. I think it was removed by somebody. So no refreshes for memory, so that means it's a lot cheaper power-wise than DRAM. No clock timing for logic. I said, really, I changed that to be no transistors for logic. And 10 times the larger memory sizes in the same footprint. So the HPC guys, how many HPC guys are here? None. So those guys want to scale their memory from, oh, I don't know, 100 gigabytes to terabytes or more, so their in-memory databases can be even bigger than they are today. This type of stuff can actually do it when it comes out. Yes, Chris?
Are you going to suggest that we should be putting all our money into Intel and Micro then? Because this seems like the most credible.
The question is, when does it come out? What is the price going to be? Where is it going to emerge? Is it just going to be an HPC niche? Is it going to replace SSD? Is it going to replace DRAM? Is it going to replace logic? It could potentially replace all those things depending on the price. Right now, the only thing we know about price is price between DRAM and NAND. That's all they've revealed at this point. So, yes?
How is this different from something like a Diablo?
So Diablo is effectively flash. It's flash in a different form factor. It's flash in a DIMM form factor that allows you to access it in literally microseconds rather than milliseconds, but it's still flash. It's a small amount of flash, and it fits in a DIMM. Now, this guy could fit in a DIMM too, and it's just probably about as dense as those flash modules would be. Somebody says denser. I won't say who, but
This will require a completely different architecture to the processor.
So my understanding, maybe it's the next page, but my understanding is that the DIMM interface is slightly changing for 3DX. Certainly, it's if it's going to be implemented as like a DRAM replacement, there might be some requirements there. But if you look at NVDIMMs, that's a whole different game. It's not. It's memory access, but it's really a storage device behind there. So yeah.
Is this also going to be on the same bus as the CPU?
I'm sorry?
Is this also going to be on the same bus as the CPU?
It's going to be on the PCIe. It can be on the PCIe bus. It can be on the memory bus. It can be out NVMe over Fabric. It can be just about anywhere in this environment. Depends on what the implementation is.
That puts the bottleneck on the buses.
But
The
you know,
I think is that this is closer than even the PCI bus sits today.
Yeah, this has to sit.
Whether
it's
or
a,
not
no.
it's
If it in the memories as a memory replacement, sure. It's really. Yes. Didn't I say that?
What it's designed to do. See that, you know, we may put it in other places because we're going to find it everywhere.
Ultimately.
Yeah.
Who are you?
Initially, that's what we're going to
So this is Leah.
Oh, hi.
She works for Intel.
Ding, 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 ding.
So some of the advantages, where it could be used. Certainly, it could replace PCIe flash for things like Pernix, storage, caching, those sorts of things. It certainly could be a replacement for DRAMs. So it can replace server-side cache. It can replace PCIe SSDs and storage modules or storage controllers. It can replace what's called non-volatile cache, so that active cache that somebody said was 20 years old and graying still exists, still very active out there. Those systems typically have some sort of form of non-volatile cache, whether it's DRAM with SSDs backed up or SRAMs or whatever it is, battery backed up storage. It can replace, ultimately, the volatile cache. So you've got, in some of your bigger monolithic systems, you've got maybe hundreds of gigabytes of volatile cache that this could all replace in one fell swoop. And I think ultimately it can actually replace the logic in computers and stuff, but I haven't quite got a reference for that. But all that means it's going to be lower cost, it's going to be denser than DRAM, it's going to be faster than NAND, and more reliable than NAND. So I've been running this analyst forecast contest. So far, I've actually got 2 or 3 people that actually are doing this with me. But I'm trying to understand how to do better forecasts of technology and when it actually comes out, how it actually gets used, where it actually comes out. And it's all based on this book I'll talk about later. But so I've got 2 forecasts for when this would. So the question I asked was, will 3DX be GA, that is generally available, in enterprise storage within the year 2016? A lot of questions there. Is there ever going to be a second source? Is it just IM? Is IM considered a second source? You know, HP Memristor has been talked about for, oh, I'd say 7 years, 8 years. Still not available. Sampling, to my understanding, is just starting. Comments?
Couldn't we just ask the lady from Intel?
I'm sorry, I was.
Sampling for 3DX RAM, 3DX NVM?
Sampling?
Yes, are samples available?
Oh, they're not available now.
Yes, so starting soon.
But will 3DX be GA by the end of 2016?
She can't say. She can't say.
But probability-wise, I guess.
She can't say. Is this the time? This is my first part. All right, so the questions are, there's a BIOS changes required to be able to boot from it. The DIMM interface changes required to support the thing. What the damn pricing is going to be is really a major adoption factor. If it's very close to NAND, then there's probably a higher likelihood of adoption. If it's closer to DRAM, less likelihood. And the other question was how many storage vendors are releasing new hardware. So this is 3D NAND. Now, it's 3D TLC NAND, which is triple level cell, and it's 3D MLC, which is 2-level cell. The question was, will 3D TLC NAND be out in enterprise storage over the next 12 months? Now, right now, Samsung's currently manufacturing this, has been manufacturing. I think they're at 2nd generation. But nobody else is manufacturing it at this point. Yes, sir?
So when did you ask this question?
I asked this question 3 weeks ago, 4 weeks ago.
So it's already there, right?
3D TLC NAND.
It's already using it, right?
Who's using it? Dell
Who?
using it, Caminario using it?
I wouldn't think Caminario as enterprise storage, but HP says they're using 3D NAND. They didn't say they're using 3D TLC.
No, 3D them.
So they're using Samsung this?
I would assume so.
You would assume so. Well, if that's the case, and I looked to see if I could find anything that HP said what their technology was.
It's a bit vague, I agree with you.
Okay. So I'll go over this, but effectively it's the same sort of question. What are the advantages? It's cheaper. Because of 3D, it's actually building up densely as well as horizontal as well as vertical scaling. And they can keep the program erase write endurance pretty much flat.
So Ray, I was talking to Samsung in November. They think they can get down quite easily to 192 layers.
1,200,
2 years.
292?
192 layers.
Yeah, so they're already at like 32 or 48-ish.
48 now, they reckon they do 192.
But they're the only people out there doing
Still
this.
the only ones yet, yeah. We know who named it TLC.
What's that?
Who called it TLC?
Well,
'Cause it's actually 8 levels.
yeah,
Triple bit.
the TLC versus MLC is how many bits per cell? That's the question. All right, I'll go. So if HP is already doing this, I'm going to have to take this down. Where it could be used, obviously, anywhere else. In NAND, storage could be used. 3D NAND could actually be a replacement. It's relatively much bigger SSD, so on the order of 3 or 4 terabyte size SSDs versus hundreds of megabytes, lower footprint. Current forecast was, yes, it was going to be available by 0.81 probability, and now if it's already available, this is moot point. Next question. Who knows about shingled magnetic recording? 1. You're the only person buying storage, though. 2, 3, OK. Thank you, Leah. So SMR is a new technology, so that when you're writing disk, you're writing more than one track. So you kind of have to lay over the same tracks over and over again. It has to be written sequentially, but can be read randomly. And an SMR disk can have multiple bands, so some bands are read or written sequentially with SMR, and some bands could be randomly read and randomly written. Currently, it's manufactured by HEST and Seagate today, available in large and small form factors. Does require a change to the SCSI protocol to support the shingle magnetic recording, cursor maintenance, and all that stuff. The real key to shingle magnetic recording is ultimately all disks will be SMR based at some point, regardless of the media type. So higher track per inch, 1.3 kilobyte tracks per inch of non-SMR. Higher density typically increases the bit error rate on disks, but with SMR you actually are able to write a bigger swath, so you have less concern about that. Supports higher density media and maintains the disk versus SSD cost advantage, which is today is about 10x without compression, deduplication, thin provisioning, all the other data reduction stuff. And lower power per gigabyte. So not only will the price per gigabyte go down, but the power per gigabyte will also go down with this, because they're more dense.
Are you seeing that get much bigger than 10 terabytes? I mean, are we hitting the limits of what's...
Well, I think 10 terabytes is, it's just today's level. It's nothing says that you can't go beyond that with an SMR type of configuration. If you want, you may have to go to one of the other media types.
Yeah. But but I mean, from a spinning disk perspective, they're already having to suck all the air out, put helium in them, and do all this crazy stuff.
Well, they always had kind of a,
kind
kind of a special atmosphere in there anyways, right? It's also ultimately clean and stuff like that.
So Ray, I know you weren't going to talk about tape, but surely tape's well ahead in terms of density.
Tape be ahead in density?
In terms of density, so is it the case that's...
Well, I mean, from a volumetric space, tape has the advantage where it's linearly based and it's coiled and stuff like that. So.
Yeah, but if you think of the advantages or the advances they've made in tape, couldn't some of those come towards disk to keep increasing the density?
Well, the funny thing about tape is actually technology-wise, the heads used in tape are actually a generation behind disk. So they're using, GMR heads for their tape versus, the stuff they're using today. So SMR also goes along with TDMR, which is two-dimensional magnetic reading, recording, and stuff like that. But effectively, SMR disks, like TLC, to some extent, is a read-intensive storage technology. You could use it very well for archive storage or a lower third tier of storage, but you're probably not going to put your random OLTP workloads on it without some flash in between or some hybrid capabilities to tier. So it's just 6 minutes. Okay, so SMR disk current forecast. There's only one participant in that. I believe it will be present in storage in the next 12 months. The SCSI protocol extensions are in the process of being approved. There are actually multiple different ways of dealing with SMR. Go all the way from this is purely compatible with random access disk, which means it's really slower, to you have to understand how the thing is actually bands are and all that stuff. Price and density differential needs to be substantial, and how many enterprise storage are going to come out with new hardware in the next year. Last but not least, NVMe Express. NVMe Express has been around 5 years. The protocol 1.0 was released in 2011. 1.2 was released this last October. It is a new method to supply faster, more parallel read-write activity in I/O to PCIe SSDs, manufactured by Intel, PMC, Samsung, Seagate, the rest of the list. There's support in Red Hat, Windows Server, Linux, just about everywhere. They're talking about NVMe over Fabric as potential technology. There's a new plug-compatible SAS NVMe plug-compatible connector they've defined. Does require new protocol drivers in the operating system, in the client, and the BIOS. The BIOS being the key item here. NVMe was architected for multi-core, which means it has optimized register and command usage to minimize the number of CPU cycles to actually access data on the device. It has the potential for better data protection because you have end-to-end data protection from the point of storage, I mean, from the RAM all the way through PCIe to the storage device, back again, have all that protected under a CRC. Lower power consumption. Allows higher performing PCIe SSDs.
What kind of level of order of magnitude or percentage higher?
From a performance perspective, I think I had something there, but it's not 10x. I don't, you know, from an NVMe, but they're pretty good. I mean, they're very reasonable. Not like NVDIMM kinds of stuff, but. So it could be used in server-side or FlashCast environments. Could be used in a hybrid, so you could have multiple levels of SSDs. You know, PCIe SSDs, SAS-connected SSDs, and you know, TLC SSDs, that sort of thing. And certainly could replace anywhere flash is used today. You could use PCIe SSDs, although there are not a lot of storage vendors that use PCIe SSDs today. Now, Pernix and stuff like that. I'm sorry. Did I make a mistake? Those kind of guys use it. So the question is, will NVMe come out in enterprise storage in the next 12 months? The answer is yes. There are 2 participants, approximately 0.8. Protocol changes to support it. OS is present, but BIOS boot support is lacking. You know, can you do a hot swap of these devices, which is real important from a storage perspective, because you want to be able to replace the device that fails. The performance advantage is not 10x. How many enterprise storage vendors are coming out with it? It's probably easiest to support this from a, you know, a pure server-side cache perspective or software-defined perspective, because all they have to do is just plug and play to some extent with the operating system. That's pretty much it from my 4 technologies perspective. I want to talk a little about the analyst forecast contest. In order for forecasts to be effective, they need to be frequent enough. I was trying to do once a week, but I've come down to once a month because once a week was too much time for me. But they need to actually have, if you've got probabilities, you can actually score the analyst. I was hoping like to have Gartner and IDC and Forrester, about a dozen other firms come up, but they're not participating for some reason. Precision is important, so you have to have a specified time frame. How long is it going to take? You know, software-defined storage is a new technology that's great, but what's going to happen over the next 12 months to software-defined storage? You need to have a probability, and it needs to be verifiable. And forecasts must expire over time. So there's this book, Super Forecasting. Another book is Signal and Noise. And these guys had created this good judgment project that ran for a course of like 4 or 5 years, where they were producing a question a week and having just anybody in the world provide a forecast on it. This is me, Ray Lucchesi. I'm the president and founder of Silverton Consulting, a one-person organization, storage analyst firm. I blog rayonstorage.com. I'm a co-host with Howard Marks on graybeardsonstorage.com. I certainly have a monthly newsletter, and that's my website. Questions? Yes, sir.
So these technologies, everything's interesting, but in my mind, it all goes back to use case. So like, if you look at InfiniFlash that came out, great, it's dense, it's relatively fast, and they don't know what to do with it.
Yeah.
Right.
Right. Well, I mean, to some extent, all this, the NAND technology is there today, right? So if it's TLC, 3D TLC NAND, it's pretty easy to plug and play, as long as it's, you know, it handles the right endurance levels of functionality that's required. The 3DX is a little different, because it can be just about any sort of memory that you want in the architecture if it's supported, right? The SMR disk requires, to some extent, some protocol changes to support, because it's sequential access disk and stuff like that. But a lot of these storage devices today have multiple tiers. So they already have kind of a slow tier and a fast tier. And if you just put down behind that like an archive tier, it's not that significant. At least I would say so. I've been on both sides of that coin, stuff like that. Any other questions?
Right.
Yes, sir.
How much do you think like manufacturing supply chain play a factor in success or failure of these technologies?
Well, yeah, I think it's a in my mind, it's a major factor in 3DX, because there's only IM flash out there. It's at creating it today. So do you as a storage vendor want to bet on IM Flash, which is a pretty big company, to survive and do well and price it competitively and stuff like that? It's not as much a factor for SMR because SMR is already Seagate and HGST. 3D TLC today, Samsung's the only vendor that supplies it, but there are at least 4 other vendors that are talking about it. NVMe is a software technology, so it's not as much of an issue.
They said the same thing though with SLC, didn't they? When EMC put SLC into
Yeah,
DMX,
yeah.
Said, there was that same discussion that you could only really get it from one place.
Yeah, that's true. It's true.
And then suddenly
It became available from others. Yes, sir.
So the interesting thing for me is that, and this is just more of a comment and a thought for everybody, is we're reaching an interesting inflection point where the capacities of SSDs are going to surpass, even with SMR and those more advanced technologies getting drives up to 8 and 10 terabytes. Samsung said at Flash Memory Summit last August that they're going to have 16 terabytes, 2.5-inch form factor SSDs by the end of 2016. They're going to be costly, sure, but
Yeah.
I mean, we're getting into those capacities now where it might become more dollar per gigabyte, dollar per terabyte cost effective to have that small of a footprint and that capacity.
Footprint aside and power aside, I don't think there's ever a point where flash is cheaper than disk on a dollar per gigabyte or gigabit basis. He said it here first, folks. They talked about crossovers for, I'm not talking data reduction, because anything you can do in data reduction, you can do with disk just as well as you can do with flash, right? So if you want to do deduplication or compression, whatever. What's that?
You can't do data reduction as well on disk as on flash because you don't have the IOPS. You don't have the read IOPS to actually do it.
Please. You want to cache it? I can volatile cache, all right? The IOPS are not an issue.
My point is that we've reached that point where the capacities surpass.
Volume? Yes. Predictability? Yes. Power? Yes. Is less sensitive to vibration? Yes. All those things are there.
So why do I continue to buy 10 terabyte disks when I can get?
Well, the question is how many petabytes are you buying?
I heard we had a whole panel on people talking about petascale and
those petascale systems, I got news for you, are not all flash.
I completely agree with that. But my point is when the capacities get to a certain point, it doesn't make sense anymore.
Yeah.
Are we getting to that point? Is 10 terabytes kind of the top of what we're
I don't think so. I don't think it's a limit for disk or a limit for flash. And that, my folks, is the end of my session. Thank you, sir.